So one way that we could do this, just get the tablet ready. So one way we could do this is we could think about pairing these numbers together. Okay, so I could pair 1 and 100 together. I could pair 2 and 99 together. I could pair 3 and 98 together. And all of these pairs will add up to make 101. So altogether there are 50 pairs that you can add up to make 101. So what Gauss very quickly realised is you can pair 1 and 100, you get 2 and 99, you've got 50 pairs of 101. So all we simply do is just say, well, rather than just do 1 plus 2 plus 3 plus 4, we just do 50 times 101 to get 5,050. Okay, and then that would be our answer. I think what Thea's done is you've been looking at the triangular numbers, I believe, and then you've just looked at, well, if you found the 100th in that sequence, you do that, and that absolutely works as well. So what we're doing here is this kind of leads us on to one of the formulae that we're going to introduce today. Okay, now an arithmetic series. So we're looking at series today, so adding up all these numbers from a sequence. So an arithmetic series is the sum of the terms in the arithmetic sequence. We often use the notation Sn to mean the sum of the first n terms in the sequence. For clarity, 5, 7, 9, 11, okay, like this. This would be an arithmetic sequence, okay, so this is just the sequence of numbers. Whereas 5 plus 7 plus 9 plus 11 would be an arithmetic series. So just make sure you know the difference between what it means by a sequence, which is just the sequence of numbers, so just writing them out, and the series is when you add up those numbers within the sequence. So the formula for working out the sum of the first n terms in a series. So you can see there this last one, which I'm highlighting in yellow. This is essentially what Gauss used, okay? He said, well, if I take the first term, A, and the last term, L, if I add them together, then I'll have half the number of those pairs, okay? So if you have, for example, with what we did earlier, our first term was 1, our last term was 100, we add that together for 101, and then we'd had 100 numbers altogether, so we've got 50 pairs of 101. Okay, and it does work as well still with odd numbers as well, if you're wondering. Okay, you might be thinking, well, surely it only works with even. It's just that when you do it with odd numbers, not every number will be paired. You'll have that number in the middle that won't be paired. So that's one way we can define the sum of the first n terms. We can also do it this way as well. It depends really on what information you've got. If you don't know the last term, then you'll be using this method. But we're going to prove both of these right now. So I'm just going to check the chat. Is there any questions? Nope. So we're going to go through this proof. Oh, by the way, both of these are given in the formula book. Okay, so you get given these in the formula book. Okay, whereas you don't get given the one we did yesterday with un equals a plus n minus 1 times d. That one you need to know, but this is in the formula book. Okay, so we're going to get into the proof of this. And this is quite a tricky proof. However, it is quite a common exam question. Now, I wouldn't necessarily say that you learn this proof line by line. The important thing here is that you learn the method of how to prove it. Okay, you learn the key step, because if you know that key step, you can kind of then easily prove it from there. Okay, but this is quite a tricky proof, so please do ask questions if you don't quite understand how to do this. But it's one that's worth, you know, every now and then kind of coming back to, so that you remember how to do this in case it comes up in the exam. So to prove this formula, that this is the sum of the first n terms, what I start by doing is I write out the sequence of terms. So my first term in the sequence is just simply a. Okay, remember a is the first term. And just recall from yesterday that un, any term, if I want to find out any term in the sequence, I find it by using this formula. So just remember that formula for yesterday because it's quite important here. Okay, so if you want to find the first term, you put in n equals 1. So that's why we just get a. If you want the second term, well, we do put in n equals 2. So that's just a plus d. So the second term in the sequence is just a plus d. The third term in the sequence, put in n equals 3 into that un. So u3 would just be a plus 2d. And then I keep going all the way up to, let's say, the penultimate term. So the one before last would just be a plus n minus 2 times d. And then the final term is just a plus n minus 1 d. So I'm just going to highlight all these, just underline these, okay, just to make it clear which is which term in the sequence, okay? So all I've done so far is this is how I would define adding up all my terms, okay, all my n terms. What I'm then going to do is I'm going to write that out again, but I'm going to do this in reverse order. So the last term in the sequence is just a plus n minus 1 times d, okay? That's just that formula that we used yesterday. The term from the second from last term is going to be a plus n minus 2 times d. And then I go all the way to my second term, which is just a plus d. And then my first term, which is just a. Okay, just, yeah, I'm going to underline these just to make it clearer. What I'm now going to do is I'm going to add both of these equations, or both of these series. I'm going to add them both together. So if I do Sn plus Sn, so just adding together the left-hand sides here, I just simply get 2Sn. Now what I'm going to do is I'm going to add the first term and the last term together. So when I do that, I do a plus a, which gives me 2a, plus n minus 1 times d. So just to make that clearer, I'll highlight this. So I've just added these terms in blue together to get that. Then what I'm going to do is I'm going to take my second term and my second from last term, and I'm going to add them together. So a plus a is 2a. D plus n minus 2 times d. Well, basically you've got n minus 2 d's, but then you add a d on, so you've just got n minus 1 d's. So we'll get this. And you can keep doing this. And if you look at the very last term, so if I add these together in green, a plus a is 2a plus n minus 1 times d, and I get 2a plus n minus 1 times d. So what we should notice there is that when we're pairing these together, you're always going to get 2a plus n minus 1 times d. So in terms of adding them all together, in total, I have n lots of those because there's n terms in my sequence. And then simply, if I want to find Sn, the sum, I just simply divide this by 2. And then I get the formula that I'm asked to show. Okay, so that is quite a complicated proof. And I'm not suggesting that you learn that line by line, but basically try and learn the method, that step that you need to write out your series, one going from a all the way up to a plus n minus 1d, and the other one starting at a plus n minus 1d, going down to your first term of a. Okay, If you do have any questions, please let me know in the chat, or if you want to go over this again in a little bit more detail, you can ask myself, Gavin, Lane, if you want a little bit more advice on this, because it is quite tricky proof. The last thing I'm going to do with this, now this actually wasn't in the question, but I'm just going to prove the other result. So to prove the second result, okay, and by the second result, I just mean this one that's highlighted in yellow from earlier, the n over 2 times a plus l. I start off with this. And all I simply do is I separate out the 2a. Okay, so the 2a just becomes a plus n minus 1d. And then simply this bit that I've highlighted in yellow, well, that is just your last term of the sequence. Okay, if you've got n terms, a plus n minus 1d is just the last term of the sequence. So that's how you get the second result. So sometimes you might be asked to prove that second result. And it might say, given that Sn equals n over 2 bracket 2a, etc., prove that n over 2 times, equals n over 2 times a plus l. Okay, so that's quite a tricky proof there. So please do let us know if you do have any questions on that. But what we're going to get onto now is actually using these formulae. Okay, so in this first question, this first example, find the sum of the first 35 terms of the sequence. So minus 4, 5, 14, 23. So for this, we want to use Sn equals n over 2 times 2a plus n minus 1 times d. You could find out your last term and use the other method, but at present we don't actually have what the last term of the sequence is. But we should know n, okay, the number of terms of sequence. We should know a, which is the first term, and we also should know d, which, remember from yesterday, d is the common difference. What do you have to add to go from one term to the next? So what I'm going to just ask you to do is give you a couple of minutes, work it out. Don't put your answers in the chat yet. What I'm going to do is I'm going to put some, I'm going to do another poll like I did at the start. Okay, and we're going to get you to put in your answers. So look out for the poll in the meeting channel. And then put your answers into that. So just have a work through that question. You might have done it already. And then what I want you to do is just put your answer in the chat. So you should see a form pop up in a minute. Just give me 1 second. So in this time, should be working it out. So hopefully now in the channel you can see. Excellent, I can see some of you have voted already. And by the way, no one can see your answer here. Okay, I can see the answer at the end myself, but no one in the chat can see your answer. So just put in what you think the answer is going to be. So even if you think it's something different, just let me know what you get. Because no one's actually going to know what you've put. And the idea is I just want to see how you're finding this, and I just want you to give it a go. Okay, so if you can't, let me know if you can't find where this is. It doesn't pop up in my chat. But it should pop up in the channel. Okay, excellent. I can see a lot of 5,215s. So what I will do then, I've just put down what we're substituting in here. We're substituting in a equals minus 4, n equals 35, and D equals positive 9. So you substitute that in and you should get 5,215 as your answer, okay? So well done to everyone that got that. So moving on to the next question. Find the least number of terms required for the sum 4 plus 9 plus 14 plus 19 plus etc. all the way to whatever number we get. And what we'll do is find the least number of terms that's going to exceed 2,000. So obviously, if we just go on to infinity, we're definitely going to exceed 2,000. But basically, what's the least number of terms the sequence needs to exceed 2,000? So how I'm going to treat this is I'm going to think of this sequence, sorry, this series having a sum of 2,000, where A is the first term of 4, and D is the common difference, which is 5. So what I'm going to do is use the formula again. So I'm going to use this again. I don't know what the last term is. That's actually what I'm trying to find. So I'm not going to use the second form of it. I'm just going to use the first form. So I'll just write that formula down there again. And I'm going to put in the sum as 2,000. N is what I'm trying to find because I'm trying to find the number of terms. So I don't know what that is at present. And then I'll substitute in A equals 4. Yeah, again, still don't know N. I'll sub in my D equals 5. So when I do that, I should get 8 plus N minus 1 times D, which is 5. And then I can just times both sides by 2 and expand the N. Sorry, expand the bracket there. So get 5N minus 5. And then with a bit of rearranging, I'm just running out of room, so I'm probably going to skip a couple of steps here. But by expanding that bracket out and rearranging, we should get this quadratic here. 5n squared plus 3n minus 4,000 equals 0. Okay, so I'm going to put another question in the chat. So just look at this on forms. What I want you to do is tell me what is, based on this quadratic we have here, what is n going to be? Okay, what is going to be the least number of terms that we are required to get? So just look out for the question in a second. I'm going to put 4 options again. And I want you to say which one that you get. Okay, and don't feel that you have to go with what everyone got. If you generally got a different answer, just put it in the chat, because I want to know if there's anyone that wasn't sure, and then I can go over this. Okay, so I can see a lot of you going for 28. So just in case you didn't get that, I will just say what answers we get. Now we do get 2 answers when we solve this quadratic. Now remember, we can just solve this quadratic on our calculators, because it's definitely a tricky one to solve. It's not one that's going to nicely go into 2 brackets here. So you get 2 solutions from this. However, we instantly want to ignore that negative one. We can't have a negative number of terms. And also we get 27.99. So we want to round that up. And we'll always want to round up in this case, because if you just took 27 terms, that's not going to take you over 2,000. You want to take the 28th term. So the least number of terms needed is 28. Okay, so obviously if you have 29 terms, you have 30 terms, it's going to take you over 2,000. But 28 is the least number of terms you need to take you over 2,000. You could also originally set this up as an equality as well. So there is also that option to set it up as an equality. But I think we can just simply set up as an equation, then just do the rounding from there. But whichever way you do it is up to you. So final two questions. So these were, I believe, taken from previous past papers. So in the arithmetic progression, the 9th term is 18 and the sum of the first 9 terms is 72. Find the first term and the common difference. So you're told in this progression, the 9th term is 18. So we need to think back to yesterday and use the first formula that we met. So we know the 9th term is 18, so we know that U9 equals 18. So that 9th term is 18. First term, we don't know that, so we just leave that as A. We know it's the 9th term, so we do 9 minus 1 for 8. And yet again, the common difference, we don't know that, so just leave that as 8D there. Then we're told the sum of the first 9 terms is 72. So we know that Sn equals n over 2. And we can now use, for this question, we can actually use the other formula. Okay, so we use that formula, but in the second version. We can use the other version as well, but it'll probably be easier to use it in this form. Okay, and the reason why, actually in particular, yes, we do want to use it in this form, because if we use it in the other form, we'd have D, which is unknown. However, here, we know that the sum of the terms is 72. We know that there's 9 terms, so n is 9. And we know that the first term, well, sorry, we don't know the first term, that's A. But we know the last term must be 18. Okay, if you're adding up these 9 terms, that we know from the earlier in the question that that 9th term is just 18. So we can rearrange this equation and we'll get that A equals minus 2. And then we can simply just sub in A equals minus 2 into this equation. And we get our common difference as 5 over 2. So just to make it clear there, we get A as minus 2 and D as 5 over 2. We'll leave it as a fraction rather than a decimal here. Okay, let me know if there's any questions and then we'll start our final question. And then it's over to you to have a go at some of those questions in your assignment. Just check in the chat if there's any questions. Oh. Okay, can't see any questions. So on to the final one. So the first term of the arithmetic progression is 7 and the common difference is minus 2. The sum of the first n terms is minus 2,900. Find the value of n. So it's quite similar to the question we did a second ago. So firstly, just write down what you know. The first term is 7. The common difference, D, is minus 2. So really get used to A being your first term, D being the common difference, what you're adding or subtracting each time. And then the sum of these n terms is minus 2,900. So what we do is we use our formula. So we're going to use the second formula. Sorry, you use it in the first form even. Okay, so we use it in this form this time. So replace the Sn with minus 2,900. N, well, that's what we're trying to find. Okay, so in this question, they're called actually a capital N, so we'll use a capital N there. 2 times A, that's 2 times 7 for 14. Then we've got our capital N minus 1 times D, well, D is minus 2. With a bit of rearranging, so timesing through by the 2, multiplying out the bracket and the bracket inside. Sorry. We should get the following. So that's just simplifying what's in that bracket inside, timesing through by 2, and then just rearrange, expanding again, and we should get this quadratic. Say, I'm not necessarily expecting you to do it this fast, but you know, hopefully you can go back and check these steps all do make sense. Okay, all I'm doing here is just some simple algebra, expanding brackets, rearranging it to get this quadratic. Then we can just simply put that in our calculator and we get two solutions, n equals 58 and we get n equals minus 50. Well, we certainly don't want that minus, so we just get n as 58 here. If you've got any questions, let me know. That is it for today. Remember, no lesson on Wednesday. Use that time to catch up. If you want to kind of do, you know, have any one-to-ones with us or just message us with certain questions, please do. It is really, really important that you do ask for help if you are stuck. Have a look at the assignment. Make sure that you do the questions that's asked of you, but do ask for help is the main thing that I want to stress here. Okay, so unless any questions, we'll end it there. I'll stop the recording now.